Welcome, my name is Dr. DrWedding, and this is DrWedding DC15. Parallel circuits. In this video, you will learn what a parallel circuit is, how to find the currents in the branches, the voltages across each resistor, and the total resistance of the circuit. In a parallel circuit, there are multiple paths the current can take when flowing from the positive terminal to the negative terminal. But no matter which path the current takes, it will only pass through one resistor. In this circuit, the current can take the green path through R1. Or, the current can take the blue path through R2. Or, the current can take the red path through R3. When drawing a circuit, a node is where three or more wires connect. It is represented by a black dot. Solving a parallel circuit is just as easy as solving a series circuit. Just a few rules change. Rule 1. Voltage is the same across all the resistors. We assume the wires do not have resistance, so they do not affect the circuit. The red section is just an extension of the positive side of the power supply. This red section is one giant node. The same is true for the gray section of the circuit. It is just an extension of the negative side of the power supply. And the gray section is also one giant node. So the power supply voltage is across all of the resistors. Rule 2. Current is additive. By drawing all of the currents on the circuit, you can easily see that the supply current is the sum of all the branch currents. Rule 3. Ohm's law. Ohm's law is used to find the missing value when you have the other two values. The best way to learn how to solve a parallel circuit is through an example. In example 1, solve the given parallel circuit. This will be done with the three rules that were just introduced. Start by creating a table and filling in the known information. Then, you just need to repeat the three rules until you fill in the table. Start by using the first rule. Voltage is the same across all of the resistors. Using Ohm's law, you can find the current through R1 and R2 and R3. Because current is additive, you can find the total current by adding all the branch currents. And using Ohm's law one more time, you can find the total resistance of the circuit. When students see the total resistance of a parallel circuit for the first time, they are often confused. They often ask, "Is this right? Why is the resistance so small when there is a 10 kilo ohm resistor in the circuit?" Yes, it is correct. The total resistance will always be smaller than the smallest resistor. To help you understand why, go back to the bucket of water on a shelf analogy for voltage. Assume there are no holes in the bucket. This represents infinite resistance and no current flow. When a single hole is punched in the bucket, the resistance is no longer infinite and current starts to flow. In this example, the resistance dropped from infinite to 2,000 ohms. If a second hole is punched in the bucket, the resistance will drop because there are more ways to exit the bucket. By introducing a 500 ohm resistor to the system, the total resistance has dropped to 400 ohms, and the total resistance is less than the smallest resistor. When the third hole is punched in the bucket, it is even easier for the water to exit the bucket. By introducing a 10,000 ohm resistor to the system, there are three paths to exit the bucket, and the total resistance has dropped to 385 ohms, and the total resistance is smaller than the smallest resistor. So, every time you add a resistor to a parallel circuit, the total resistance will drop, and the total resistance will always be smaller than the smallest resistor in the circuit. Here is example 2. Find all the currents and voltages for this parallel circuit. Then, calculate how much power each resistor is dissipating. Finally, select the appropriate wattage rating for each resistor. Start by creating a table and fill in the known values. Then, you just need to repeat the 3 rules until you fill in the table. Using the first rule, you can get the voltages across all 3 resistors. Using Ohm's law, 3 times in a row, you can find each of the branch currents. Because current is additive, you can find the total current by adding all the branch currents. And using Ohm's law one more time, you can find the total resistance of the circuit. The power dissipated by the resistors and the power delivered from the supply can be calculated using the equation P equals V times I. In this series, I am using a safety factor of 2, but your professor or textbook may use a different safety factor. Because the safety factor is 2, you double the power and round up to the nearest resistor wattage rating. The total wattage rating is not a resistor wattage rating. It is the minimum power the supply must be able to deliver in order to power the circuit. Some people may use a safety factor of 2.5 or 3 for this one value. Here is example 3. Find all the currents and voltages for this parallel circuit. Then, calculate how much power each resistor is dissipating. Finally, select the appropriate wattage rating for each resistor. Start by creating a table and fill in the known values. Even though the circuit has different initial conditions, it is still solved the same way. You just need to repeat the 3 rules until you fill in the table. You will just use the rules in a different order. In this circuit, you will use Ohm's law first. This will give you the voltage across R1. Once you know the voltage across R1, you will know the voltage across all the resistors as well as the supply voltage. Using Ohm's law, you can find the currents through the other 3 resistors. The sum of the 4 branch currents is the total current. Using Ohm's law, you can find the total resistance of the circuit. Using the power equation, you can find the power dissipated by the 4 resistors and the power the supply is delivering to the circuit. Using a safety factor of 2, the power for each resistor is doubled. It is then rounded up to the nearest resistor. As before, the wattage rating of the total is the minimum value the power supply must be able to generate in order to power the circuit. Example 4 is the last example in this video. You should pause the video and see if you can solve this problem by yourself. When you are finished, restart the video and you will see the solution. Here is the solution to example 4. I hope this video has helped you understand what a parallel circuit is and how to solve them. If you find these videos helpful, please like the video, leave a comment, and subscribe to my channel. This is the only way I can continue to make these videos.